Hi again, everyone. Thanks so much for being here and thanks for the opportunity. I'm just going to go over some of the introduction part, and Drew and I are going to share some of the slides with you guys. So I'm going to start off first. So about Owens Corning, we founded in 1938, and this is a company that has been around for a long time, and also has been a Fortune 500 company for 66 consecutive years. We are a global manufacturer in 33 countries in over 19,000 employees, and our revenue as of 2022 was about $9.8 billion. Furthermore, sorry, I forgot to mention that we are also in three different industry segments of insulation, roofing, and composites. Drew and I are part of commercial insulation section. And also here you will see some of the very common and popular brandings of Owens Corning in terms of commercial insulation. On the left corner side, you will see fiberglass, Foamular, foam glass, and thermofiber. So fiberglass is branding for our glass fiber product, which was the first product of Owens Corning. Foamular, which is our extruded polystyrene foam insulation, and the foam glass, which is our solar glass, and finally thermofiber, which is our mineral wool insulation. And as you can see in this rendering, from bottom to top, exterior, interior, there are multiple areas that you can apply all these products. And basically, if you have an application, there's a good chance that we have a solution for it. So what is new? There are a few product development in recent years, but Owens Corning, although they're not too new anymore, because what I'm going to share here is about our Foamular NGX, which stands for next generation of foamulars that we had in the market. But this basically came to the market in 2020, so about 4 years ago. And this product has 90% less global warming potential compared to the traditional product that we had in the market. And all the green states are the ones that already adopted this new innovation, and the pink one are in transition. So as I mentioned, it has 90% less global warming potential, and that was doable and possible by eliminating HFC 134A, which is the blowing agent that used to be used in production of this product, or the traditional XPS product. So this is pretty much equivalent of every 10 board that you replace it. But this product, it is equivalent of taking one car from the road for 1 year. So it's pretty significant in terms of the effect and global warming potential. So thermal fiber rain barrier, which is our mineral wool continuous insulation product. Years ago, we came up with this new product, which is HC, rain barrier. HC stands for high compressive strength. So this basically allows for minimal penetration through the attachment using this thermocrimp technology for the best compressive strength and thermal efficiency. So with this, you can use direct attachment mechanism, which is through the screws that goes through insulation, gypsum board, air water resistive barrier, and framing, and you don't really need to use all the traditional cladding attachments like clip-on rail system or other basically common methods. So it's preferred when basically the application is right for it. Also, a couple of years ago, we introduced Rain Barrier Dark, which is basically our continuous insulation mineral wool product that comes with black facing. That allows for eliminating the additional need for camouflage for the field application or in the open joint and rain screen application. So that kind of blends in with the rest of the facade and the exterior and basically hides this mustardish color of mineral wool. Also, not to forget that we're provider of engineering judgment for perimeter fire containment. So as you can see here, we've tested so many different assemblies. So in case if you come up with facade with different geometry, or if basically your facade extend below the foundation, or you have a wider safe off area, these are all examples that we can provide engineering judgment. And also recently, last year, we came up with this new assembly, which is a zero spandrel assembly, and you will see the Intertech listing number up here if you're interested. So this is basically a new zero spandrel assembly in the market. Achieves 2 hours as well as 3 hours fire rating if it tested per ASTM E22307, and compared to the similar assemblies, it is much easier to install it either in the field or shop applied, and it comes with the fewer fasteners and materials. So overall, makes it the least expensive assembly in the market and enhances this facade design flexibility in terms of having this floor to ceiling glass. And also it complies with the IBC requirements that basically prevents the need for relying on this exceptions per IBC. And as you can see, it features some new products such as FireSpan 120 as well as Impasse 2, which are new products that we came up with in order to support this assembly. And as well as the safing material, and this is basically a schematic of the safing that you can find in an Intertech listing. With that being said, Jeff already mentioned about that we are AIA provider for this course, and the AEC daily link is going to be provided to you guys after completion of this course, so you can just register yourself and get credit for this session. As far as the learning objectives goes, we are going to learn about the fire safety objectives of NFPA 285 and its development history, understanding how ASHRAE 90.1 continuous installation air water resistive barrier requirements have contributed to the rise of NFPA 285, and also some of different building situations that require NFPA 285 based on IBC, and also how to design for NFPA 285 compliance. Okay, let's just start with the basic. What is the NFPA 285? NFPA stands for National Fire Protection Association, and 285 test method is a test that evaluates fire propagation characteristics of exterior wall assemblies that containing combustible component. And this is a test trick that we're going to talk and explore more in the future slides. But for now, basically, this is a test that in the laboratory environment, basically test for NFPA 285. So why NFPA 285? So basically, NFPA 285 was developed to measure what happens during the fire when a non-combustible building is wrapped in combustible material. It is triggered when the IBC requires non-combustible wall construction. However, Energy Code requires some sort of combustible material, such as air water resistive barrier, such as continuous insulation that some of them are often combustible, like foam insulation, and also combustible exterior cladding. All of this are combustible and could trigger NFPA 285. So why NFPA 285 is important? It is important because it can impact the fire performance of the building, and historically it's been contributed in some of the fire tragedies, basically globally. And I'm going to go through some of the examples of that. And first, you will see the Wushin Golden Suites in Korea. So this the building is was a 38 stories building that the fire started in on the fourth floor in the service room, and it was because and it spread around because of the combustible paint on the exterior of the building. Also, on the second example, this is the Oriental Hotel in China. This is again another high-rise building in Beijing, China, that there were some fireworks around the building, and because the sprinklers were not working, it was still in the construction phase, and basically this fire spread within 13 minutes in the entire building. And finally, you see the Monte Carlo Resort and Casino in Las Vegas. So this fire happened in 2008, and some welders were working on the roof. And the exterior of this building was eaves. However, that was not the reason for the fire, but there were some decorative bands that were combustible, that were applied on the eaves of basically the exterior of the building, and that caught fire and basically drove the fire on the entire building. I'm sure all of you guys are familiar and heard of the Grenfell Tower in London. So this is the Grenfell Tower in London, and this is basically after it was remodeled back in 2017. This building was built in 70s, and in 2015 they recladded it, and this is the picture in 2017 before it caught fire. So the fire was pretty tragic, as you can see here. It shows that it basically spread rapidly from side to side and bottom to top. Over here, basically 70 lives were lost, and also a lot of injuries. You can see here that how it basically vertically the fire escalated, and you can see the cladding and insulation behind the cladding, and some of the charred insulation that are hanging off the wall and the window. So there are different theories behind that, but basically the reason for the fire is three different elements. Well, first of all, they use in the overclad system that they use, there was a polyiso foam insulation, which is a combustible foam plastic. Also, there was an airspace here, which is full of oxygen, and obviously it acts as a fuel for the fire. And also cladding, which is MCM, or metal composite material panels that are also made of a combustible core of polyethylene, which also is a combustible material. So altogether drove this fire. So now that you know the importance of NFPA 285, let's talk about the history of that. So NFPA has been in codes in different forms since 1980s, but what basically put it up front was years ago application of EAFs, which featured basically EPS, exterior EPS for energy efficiency, and obviously EPS is a combustible material, and that raised some concerns among the fire marshals of San Antonio. That's where like this building was built and featured EIFS for the first time in North America and the United States. So they were very concerned about the impact of combustible material in the exterior of the building, in the event of fire, and how it could impact the fire performance of the building. So over here in this chart, you will see some of the building code history in terms of NFPA 285 that started to basically be part of the codes and standards in mid 80s. Here you see that SBCCI basically requires some sort of diversified or full-scale testing, and then BOCA in 1984 required also the same sort of requirement for testing for the exterior walls. And then IBCO modified this for a full-scale multi-story test, and eventually reduced the scaling to intermediate tests and in the lab environment. And finally, NFPA adopted the consensus standard of NFPA 285, which was based on the UBC that ICBO developed, and then back in 2000, IBC adopted and required NFPA 285 as a fire performance requirement, and it's been around since then and is still a requirement. So what is driving NFPA 285 today? So the answer is increasing requirements and awareness around the need for continuous insulation and continuous air water resistive barrier. So as you can see here, continuous insulation started becoming common, a requirement starting 1999, and air water resistive barrier became as a requirement in ASHRAE 90.1 starting 2010. So all of them pretty recent over the last 2 to 3 decades. So basically, you will see that a wall system that was more like the what you see on the left side of the screen with the stud cavity insulation converted to a more complex version of it, which is on the right side with continuous insulation, air water resistive barrier outside of the gypsum sheathing. And also in this chart, you will see the prescribed level of continuous insulation in the ASHRAE 90.1. Basically, in all the regions except region 1 or zone 1, you will see that the amount of continuous insulation increased drastically since 2004. And as an example, you see zone 5, that how much continuous insulation increased from 3.8 to 10 to R10, and the same applies to pretty much most of the climate zones. So now that we have a little bit of understanding about history behind NFPA 285 and what make it more popular these days, and the importance of it, so let's look at what IBC requires in terms of NFPA 285. So as we discussed earlier, NFPA 285 has been required in IBC since 2000, and it is still a requirement based on the latest revision of IBC, which was in 2021. So NFPA 285 is required per IBC for 4 different types of constructions, which are type 1 to 4. And this 4 types are basically non-combustible building types that required non-combustible exterior walls of different types, and the definitions are also here, and I'm sure you all know. So the only thing, the only type per IBC that doesn't require NFPA 285 compliance is type 5, which is basically allows for any materials that are permitted by the code and pretty much covers or applies to residential houses. So here you will see that different building elements that are used in non-combustible exterior walls and different fire ratings per IBC. Also, when and what part of the IBC covers this different building elements, and when they became first or when they appeared for the first time in IBC in terms of being required to be tested per NFPA 285. Okay, so when is NFPA 285 required in IBC? So per IBC, there are several different places, actually 4 different chapters that covers and talks about NFPA 285. The first chapter is chapter 7, which is on fire and smoke protection features. In this chapter, that also talks about fire blocking, it says that exterior wall coverings that have concealed spaces, they need to have fire blockings in this concealed spaces of exterior wall assemblies. However, if this wall assemblies are tested per NFPA 285, then they don't need to have fire blocking. Also, chapter 14 of IBC talks about exterior walls and also water resistive barriers, and explains that if the building is greater than 40 feet tall, then and they have a water resistive, combustible water resistive barriers, then they need to be tested per NFPA. Additionally, metal composite materials or MCM and high pressure decorative exterior grade compacts laminates or HBL material are all combustible material and needed to be tested per NFPA 285. Chapter 15 is on roof assemblies and rooftop structures, and here explains that as part of the roof assemblies, you can have this mechanical equipment screens as long as they're tested per NFPA 285. Chapter 26 is on the plastics. Over here explains that regardless of the height of the building, if there's any sort of foam plastic insulation or foam plastic materials used on the exterior of this wall assemblies, then they need to be tested per NFPA 285. And the same goes to fiber reinforced polymers or FRP materials. So before going further, just have a very quick question for you guys to just contemplate on. And it is, if we have a combustible wall product that has been tested for NFPA 285, can we use that product in any other wall assembly? So again, you have a combustible wall product that is tested per NFPA 285, and you want to know if the components of this wall that has been tested are applicable in other wall assemblies that are required to be passed for NFPA 285. So the answer is no. And the reason is NFPA 285 is an assembly test, is not a product test. So to make it short, you are not allowed to substitute similar components from other manufacturers in a tested assembly, or if there are tested components, they cannot be used in different assemblies. Okay. Now I have another question. Which continuous installation does not trigger NFPA 285 compliance? As you can see here, there are different types of continuous insulation in the market, which all of them could help with thermal performance, but they're very different in nature. And mineral wool here is the only one that is a non-combustible material and under no circumstances triggers NFPA 285. So although 2012 revision of IBC revealed so many different scenarios that require application of NFPA 285 and compliance with NFPA 285, 2015 revision tried to reveal some of the scenarios and explain better based on some of more available tests in the market. So we're going to go through some of these changes that happens since 2012 revision. Chapter 26 was on foam plastic continuous insulation. So you will see that in section in chapter 26 and IBC 2012, there is a requirement for vertical and lateral fire propagation, which is basically NFPA 285 test. And that is required for foam plastic in any height. The only exception is if the building is a one-story and sprinklered and covered with metal. In 2015 revision, you will see there are more explanation that added to this section, and it is there is an exception here besides having one-story building and fully sprinklered and covered with metal, and that's when basically this foam plastic is covered on each face with minimum of 1 inch masonry or concrete, and there's no airspace behind. And also foam plastic has a flame spread of less or equal to 25, and airspace is maximum of 1 inch. And you will see that all those exceptions were carried over to the latest revision of IBC, which is IBC 2021. On the water resistive barrier, you will also see some changes in 2015 revision, and that is when you had in 2012 that if you have any building over 40 feet above the grade, and if you use combustible or water resistive barrier, then they need to be tested per NFPA 285. In 2015, you see some exceptions. Well, first of all, you see some explanation here that makes it clear that if you have fenestration products and flashings, these are not considered part of the air water resistive barrier. And also, couple new exceptions. First explains that where water resistive barrier is the only combustible component and in the wall, and as long as it's covered with brick, concrete, stone, terracotta, stucco, or steel with a minimum thickness requirement, or if this material's peak heat release rate or total heat rate is in compliance with ASTM E1354, and the flame spread and the smoke development or a smoke developed rate of this material is compatible with ASTM E84, then this material is an exception, and this building is this wall doesn't need to be tested per NFPA. And again, the same exceptions carried over to IBC 2021 revision. Okay, now that you know basically about IBC, importance of NFPA 285 and everything, let's look at the test itself. This is the test rig that we saw in the beginning of this session. Basically, this simulates two-story building. You have an upper room and lower room, and also you will see two burners. There's a room burner and a window burner. So first they turn on the room burner and they let it burn for 5 minutes. And after that, they turn on the window burner and they push it in the window opening, and they allow both burners to continue to burn for 25 more minutes. So the whole test is about 30 minutes in total. And during this test, they monitor two things: the fire propagation, the spread of fire vertically and laterally, as well as the temperature rise within the wall cavity and exterior wall with thermocouples. So let's look at this criteria. In terms of maximum allowable fire spread, So there's a 10 feet vertical and 5 feet lateral from the window center line. So as long as the fire spread happens in this radius, it is allowed, and it is basically passing test. And this is an example of this test that has been done, and you see different pictures for during the test and after the test is done and the cladding is removed. And this is also the same test, which was basically the Silestad masonry veneer wall system. Again, different angles from the front, from the back. So basically what we see here, the extent of the fire that could be more than 10 feet versus the previous slide that you see less extension. So one could be passing, one could be failing. Also, we talked about the temperature rise in various locations of exterior walls. So they have 3 different sets of thermocouple that they place it in the core of the exterior wall. They put it on the interior face of exterior wall as well as in the air cavity. So when it comes to temperature rise, there's 1,000 degrees Fahrenheit criteria for the exterior face as well as for the air cavity. As long as this thermocouple should, the temperature rise is less than this, so this is good to go. Now, when you look at the interior face, which is basically the thermocouples that are located in the inside of the exterior wall of upper room, there's a different temperature rise criteria, and that's 500 degrees Fahrenheit. So half of the criteria for the exterior. So again, you'll see here that all the thermocouples show temperature rise less than what is required. So altogether, if all these temperatures are basically less than what is allowable, this is passing test as well. So there are a number of different tests when it comes to the fire performance of the buildings, especially commercial buildings, that needs to be met, and one of them is NFPA 285. However, there are at least a couple more tests that could be similar, but very different in nature. And the purpose of this slide is to explain it a little better so you know how they're basically different from each other. Another very popular test in terms of commercial building is ASTM E119. So this is mostly for interior partitions, and this is a structural fire resistance. And basically the premise is here to limit the fire propagation from one side of the wall to another. Second test, which you can see the image in the middle of this slide, is ASTM E2307. And this is for perimeter fire containment, basically application. And the premise is here, limiting the spread of fire through the voids in the floor line. And finally, you have NFPA 285. Again, very different tests. The first 2 tests, ASTM E119 and 2307, are hourly rating, and NFPA 285 test is only 30 minutes test. And promises here is basically limiting the fire propagation on the exterior walls of non-combustible building types, and basically it examines the growth of the fire on the surface and inside the wall cavity. Also, it's important to know that there are some similar tests in NFPA 285 that are applicable in Europe and Canada, but not in the US, so not to confuse them. With that being said, that brings us to the second half of this presentation, which talks about some of the changes in the recent years in NFPA 285. And here I invite back Drew to cover the first chapter of our course.
All right, great. Thanks, Sabora.
Thank you.
Great job. Can you see my screen now?
Yes.
Okay, great. All right, let's keep moving. So So what's changed, right? So NFPA 285, as Sabora was explaining, has been really included in our building codes in some form or another for a few decades now, and has been in the IBC since I think 1999 or 2000, I think it was. So, but there have been a few changes over the years, and so I'm going to highlight a few of the simple changes that have occurred maybe over the past 5 to 6 years or so. First of all, you can buy a copy of the NFPA 285 guide here, not from Owens Corning, but from the National Fire Protection Association, right? So, quick plug for them, and it is it's about, I'm going to guess, oh, I don't know, it's probably about probably about 30 pages or so, but it goes into great detail about everything that Sabora was just talking about. But in recent years, they had a slight title change. They took out the words non-load bearing from the title of the test, probably just to acknowledge that many of the walls are indeed load bearing as well. They did make a couple of new requirements. So in the event you are testing a panelized cladding system, now with some exceptions, when you have an assembly that features vertical or horizontal joints, they require as part of the test that you include joints over the window head during the NFPA 285 test. They removed a 10-minute observation period. That's no longer required. And then when it comes to the window head, the jamb, the sill, these pretty important details. They did clarify some verbiage there. They require that the window opening, the head jamb and the sills, be closed off with a maximum 0.04 inch or 1 millimeter aluminum flashing, or the test sponsor, be it an association or a manufacturer or whoever's sponsoring the test, they could provide their own details for how they want to conduct or treat the window head, jamb, and sill. So it's one or the other. They did add some definitions in there regarding exterior wall materials. We've all been talking about walls for years and years and years, it seems, but there's still oftentimes some disagreement regarding what some of the terms mean. So they laid that out. And they also added some additional guidance in terms of things like sealing the edges of the test specimen and so forth. So they've been cleaning up the test procedure a little bit to try and tie up some loose ends, it seems. But overall, everything that Sabora just described is really accurate. And they did, in fact, add a section on the end called Annex B. And this is really just some guidance around engineering judgments. So if you're working with a fire engineer or somebody within your firm wants to consider an engineering judgment for a wall assembly to see, okay, we're going to tweak this, this, and this, would that still comply with NFPA 285? There's some guidance in there to help you think through some of the considerations. So, all right. So those are some of what's new over the past few years. Now I'm just going to jump into complying with NFPA 285 and some of the key details to consider. Of course, when you're designing a compliant wall assembly, you really need to take into account all these different layers and components of the wall, because as Sabora said, it's not a product test, it's an assembly test. And so we'll look at the structural wall, the stud cavity insulation, CI, and more. And there's actually little things that are new in each one of those sections. So we'll walk through those quickly. When it comes to the structural backup, there's been lots of testing on walls that have a CMU or a steel stud backup. And just over the past 2 or 3 years, there's even been some wood stud testing completed, some fire retardant treated wood stud. I think that was conducted by one of the industry associations. So, and really just referring to the framing there, not necessarily the OSB that's shown in that picture. Moving into the stud cavity, there's assemblies with a lot of different options. You can have an assembly that has no insulation in the stud cavity between those framing members. You could have fiberglass in there, mineral wool, even some with some spray foam. You can have wall assemblies that feature a gyp sheathing on there or no gyp sheathing. Maybe it's just a rigid insulation board direct applied to the framing. So again, we've seen passing tests with all these different options there. And there are a lot of continuous insulation options on the market. Of course, if you're in a climate zone that allows you to get away with no continuous insulation, that's still possible here and there. But for the most part, we're seeing these other options being incorporated into our exterior wall designs: mineral wool, polyisocyanurate, expanded polystyrene, extruded polystyrene. And I always like to point out there, the one of these that really stands out in the group is mineral wool, primarily because it's the only non-combustible continuous insulation option in the group. So that component alone would not trigger the need for NFPA 285 compliance. But of course, there might be other components in your wall, like the air and water barrier or cladding or other components that could trigger the need for NFPA 285 compliance. And of course, there's other differences between all those options too, and when it comes to moisture vapor permeance and R value per inch and things like that. Moving on to air barriers. So this is really interesting. Of course, the ASHRAE 90.1 started requiring air barriers in our wall systems in 2010. And many of those, if not most, are combustible. So they are one of those components that's going to trigger the need for NFPA 285 compliance, depending on some of those exceptions that Sabora outlined earlier. But over the past few years, we've seen a real proliferation of air and water barriers, I would say. And there's been some new products and name changes and so forth. And along the way, we've learned that some of them can contribute to the fire a little bit more than others. And that can impact maybe how some of the detailing is completed as well. So here's just an example of some of the proliferation that's happened. Back in, this is three kind of blurred out illustrations of industry NFPA 285 design guide. And in this one from 2014, there was only 11 air barriers in that design guide. Fast forward 2 years, now there's 70 air barriers in that guide. And in the one from 2021, we see 76 different air barrier options. So clearly it tells me that there's been a lot of testing done. We've learned a lot about how these products perform. And then even in this image on the right, you can see there's a lot of colors there as well. And so what that's referring to is, or acknowledging, is that even based on the type of continuous insulation or thickness, that might pair better with different air and water barriers. So an air barrier that works well with 3 inches of XPS might not work with 5 inches of XPS, for example. So we're really getting into the weeds in some of our design guides, and there might be some implications around the details too. Moving out to the cladding, I generally put the cladding into 2 buckets. Combustible or low mass cladding is shown on the left. So your ACM, is kind of the low mass. High pressure laminate would be a combustible. Thin coat stucco, hollow terracotta, and fiber cement all fall in that bucket. And then you have your non-combustible or high mass claddings, masonry, concrete, traditional 3-coat stucco, traditional terracotta, pretty heavy concrete, stone. Thin brick could fall into that bucket as well. And so what we've seen over the past years is we've seen this, because of the way, terracotta has kind of evolved. They've included more air pockets in the panels and so forth to lighten it up and so forth. We kind of throw it back in the lower mass cladding bucket. And then thin brick was added here just because there have been some new thin brick assemblies tested per NFPA 285. When it comes to selecting a continuous insulation, of course, like we talked about a few slides ago, there's a lot of things to think about. And one rule of thumb that I generally start with is that the continuous insulation is oftentimes driven by the cladding choice. And here's what I mean by that. So if you have a high mass non-combustible wall, like a brick veneer here, you've got a lot of options. That brick is non-combustible. It's, of course, high mass. It's going to do a wonderful job of protecting that wall from flames. And so you've got a lot of options in terms of XPS, mineral wool, maybe a fire enhanced polyiso. But if you were to shift to one of these other rain screened assemblies with maybe a lightweight or combustible cladding like metal panel, high pressure laminate, some open joint systems, that kind of takes XPS out of the equation. And then you really have to choose between a mineral wool continuous insulation or a fire enhanced polyiso foam plastic. So this is just another way to say the same thing, is that a thermoplastic XPS can generally be used behind these non-combustible high mass claddings, brick, stone, stucco, but not quite behind these other cladding types. This is a better fit for mineral wool or a fire enhanced polyiso. Or here's where the presentation makes a liar out of me. There has been some testing of this assembly. They call it a CI protected assembly, where if you look in the at this illustration here, you can see they kind of reverse the order of the gyp sheathing in the foam plastic CI. They say, hey, let's put the CI against the framing members and then put the gyp sheathing outboard of the CI with the weather barrier out there as well. In that case, this gyp sheathing is doing a nice job of protecting the combustible foam plastic CI. I don't see that done too often. Usually it's, and it probably was born out of a oops, we built the wrong wall on site, and then we had to get an engineering judgment and so on and so forth. And then somebody decided to test it to make sure that solution actually worked. But we do see that. One of the most important things to pay attention to, especially if you're specifying like a foam plastic continuous insulation, is the headers. And even more specific, like an extruded polystyrene continuous insulation. Here we're showing it, and these are all assemblies that are somewhat approved or have been tested and passed using these details. So on the left, you have a fire retardant treated wood closure there at the window head. As you can see there with this loose lintel or adjacent to it, that does a nice job of protecting the combustible materials in that cavity behind the brick. In the middle, you've got mineral wool, a compressed mineral wool between that loose lintel and the face of the gyp sheathing and the air barrier there, and that does a nice job of protecting that combustible CI as well. It's almost like a little bit of a how you treat the top of a fluted deck or a poke through penetration. You're just friction fitting like a safing insulation in there to protect that CI. And then all the way on the right, we have a solid steel angle. As you can see, goes all the way from almost the face of the brick back to the structure there. And of course, that steel is going to do a heck of a job, protecting the CI in that wall. Okay. And there's just a couple of images there from some job sites we've been on. Opening details, all right, at the jams, pretty similar approaches here. In this case, the fire retardant treated wood closure there could be used in a jam to protect that cavity. Here in the middle, compression fit mineral wool. And on the right, you could even have a brick return, right? Very aesthetically pleasing. Maybe not the most thermally efficient, but it'll sure do a nice job to protect that CI and air barrier there. Here's some images of all three of those approaches that we've seen implemented out in the field. And as an option here, and pardon the color goof there, it looks like. That should be on the that CI. So as an option, depending on the thickness of the extruded polystyrene in this case, you might be able to get away with no closure requirement at the jamb or even at the sill. Turns out that it just wouldn't create enough fire to be problematic or fuel the fire quite so much. But once you start getting over 3 or 4 inches, that's when those closure details are especially important at the jambs and the sills. Okay, and then at the sills, speaking of, here on the far left, we have a stone cap option there that could be used. In the middle, we have a mineral wool safing, again, that compression fit safing insulation. And on the right, again, depending on the thickness of that XPS, a closure plate could be an option, that 0.04 inch maximum closure plate that they talked about in the NFPA 285 test itself. There's an example of a solid brick return as well. That could be an option. All right, compliance documentation. You've got your wall designed, and now you just want to make sure it's fully documented to showcase the compliance and so forth. There's a few options there. Of course, you could design using some of those exceptions that Sabora outlined in the IBC. There might be some, I would say maybe somewhat rare opportunities to design a wall that was made of all non-combustible materials or incorporated. Maybe it was just the WRB was the only combustible material in the wall. Maybe if it's paired with a non-combustible cladding and a mineral wool CI or no CI and so forth. So using those, sorry about that, using those, I'll jump back 2 slides on me. Using those exceptions is one way. If you just can't find an assembly that seems to match your unique design, you could always, I'm sorry, in this case, you could just use a tested assembly if you have a pretty commonly designed wall assembly. Chances are there's been an assembly tested. There's so many combinations of all those exterior wall materials, it's nearly impossible to test everything. But there are a handful of tested assemblies out there. But honestly, for the most part, we see people using option 3 here on the far right, securing an engineering judgment or extension letter from either a manufacturer or a qualified fire engineer. And just again, because of all the different combinations of materials and new materials coming out on the market, we see that being, one of the most popular ways to help document the assembly. Had another thought there, but it escaped me. But that's the idea. Let's keep going. In terms of documentation, you might be able to get your hands on an actual NFPA 285 test report from one of the test labs or manufacturers who sponsored the test. A lot of times they don't want to part with the test report, not because they're trying to hide anything, but because it might, in their opinion, might have some proprietary information that they don't want the competitors to see, because it might inform some future product innovation or system innovation. But if you can, they're excellent ways to document it. It's sometimes they're 50, 60, 70 pages long, and they've got all the details in there. I think I mentioned that on the next slide or two. Again, engineering judgments from a qualified fire engineer, manufacturer literature is excellent, or even a test listing. So yeah, here's kind of an overview of what you might see in an actual test report. Again, they're pretty expensive to run. These are probably pre-pandemic price levels, $25,000, $35,000. And it's going to take several months to get that test ready. And then depending on the type of wall you're testing, you might have to build the wall and let it sit for 30 days to cure and so forth. So it's a pretty involved process. There's 3 test labs here at least. I think there's 4. Maybe UL is not shown here, but Intertech, Southwest Research Institute, UL, all good places to conduct the test. And that report is going to be very detailed. When you're done with the test, it's going to have outline of all the materials that were used, including the brand names, the thickness and sizes and all that, and the way it was configured and all the details that were used around the window penetrations and so forth. So you get a really good sense for how that wall was constructed in the actual test. All right, if you can't get your hands on an actual test, which is not surprising, there's these third-party consulting engineers who can do an engineering judgment, or you might be able to, again, get it from a manufacturer. UL or others might be a good source for that too. But honestly, I would start with the manufacturers. Anymore, these are just examples of different NFPA 285 design guides from different manufacturers, and they do a really nice job of outlining all the different component options, and they're laid out in a way that allows you to go layer by layer of the wall and essentially kind of mix and match a refined set of components that the fire engineers believe would work well together and comply with NFPA 285. So in these tables, or in these pieces of literature, are essentially just prettied up versions of the engineering extension letters and judgments from the fire engineers. And here's an example of one excerpt of a design guide. So you can see here, here, in terms of the cavity insulation, you could have none. You could use a fiberglass. You could use a mineral wool. Any other non-combustible insulation, faced or unfaced, even a spray foam option in that particular option. Under exterior sheathing, you could use no sheathing, or maybe it's a 1/2-inch glass mat face or a 5/8 type X glass mat faced gyp sheathing. Weather resistive barrier here refers to Appendix A, where you might have 60, 70 different air barriers to choose from that are kind of separated by permeable, impermeable, sheet applied, fluid applied. These manufacturers are really getting into the weeds. Different drainage plane options, exterior insulation types, could be XPS or mineral wool or polyiso, all those ones that we kind of talked about earlier. So they're making it more simple all the time to really walk you through the design and compliance option. One option, if you are at the beginning of your search and you want to try and find an actual test that had been completed, some of these test labs have online databases. Like here's a UL Product IQ website. If you just search for UL Product IQ, you'll find your way to this site. You can create a free account here, I believe, and then you can type you can start a search typing the letters FWFO. Not quite sure what that means. I don't think it's an acronym for anything, but FWFO, if you type that in, click search, it'll give you a listing of some NFPA 285 compliant assemblies, and you could click on it further to get more details about that test, just like any other kind of fire rated test you might like to search for, like a 1, 2, or 3 hour test, and you want to look at a UL listing. It's along those lines. So you'll find some amount of tests in there. It's certainly not comprehensive because they're not posting the tests that have been done at other test labs and vice versa. So, all right, let's bring it home. We've got a quick summary slide here. Sabor did a great job of talking about just the general fire safety objective of NFPA 285 and a little bit of a history lesson about how it came to be and how it's been in the codes for decades. But we're really seeing it more and more today because we're starting to incorporate these combustible materials into walls that are supposed to be or otherwise non-combustible, like construction types 1, 2, 3, and 4. Sabor talked about ASHRAE 90.1 again and how those are contributing to the rise of NFPA 285. We talked about all the different building situations that require NFPA 285 and the IBC. It pokes his head up at least 3 or 4 different chapters there in the IBC. And then we explored some of the, the test standard in detail, talked about the test rig, how the test is conducted and so forth, and some steps we can take to design for compliance and document it all. So Sabora, sorry your picture is not on the end slide here, but this is my presentation and not yours. So, but I will let me stop sharing, and we can take a look at maybe some questions and so forth that folks might have. Oh, there we go.
Great. Thanks so much, Drew.
Sure. Did you see any questions come across in
I
the chat?
didn't see any new questions. I saw some questions regarding to how to get a credit, LU credit for this course, which seems like Jeff addressed them very well. But if you guys have any more questions, let us know.
Yeah, great. Is it, me being in Chicago, we see continuous insulation all the time now. Are you seeing it on your projects more and more in the Orange County area, or is it still kind of depending on the project and so forth? Do you have what's the trend out there? Anybody care to chime in? I think you guys are under a different code too, the Title 24 and maybe some other stuff that I'm not used to seeing here.
And if anybody wants to just take themselves off mute and answer the questions, please do so. You don't have to use the chat at this time.
Sure.
I do see one from Betsy saying almost always.
Yeah. Oh, okay. Yeah, good. Yeah, it definitely is. The CI is pretty impactful, so I'm even starting to see it on some residential, like single family homes in my neck of the woods here.
Yeah, especially in that region.
Yeah.
Or
With the 15 below, it sure comes in handy. Yeah.
Yeah, 15 degrees.
Yeah.
So definitely.
Yeah.
So if you guys have any questions, let us know. I believe we can spend a couple more minutes here. But also we have shared our contact information, our email address, and that could be also found on the AIAOC website, where like you see the advertisement for this course. So if you have any questions, feel free to just email us. Again, I'm based in California. I'm based in Orange County, and I'm your local representative of Owens Corning. So I would be more than happy to address any questions, or if you have any in-person lunch and learn inquiries or product knowledge shows, we would be more than happy to be there and basically offer that. If anything else is left, Drew, if there's anything that you would like to cover besides
I think you've said it all, Sabora. I would just say thanks for having us today. It's really great. I love being able to participate from afar.
Sure.
And call Sabora if you have any questions.
And we have some guidelines, NFPA 285 design guide, and really good handy instruction for a lot of different things related to continuous insulation. So if you guys are interested, just let me know. I can send it to you. And the recording for this webinar is also available, and we can also provide a PDF of the presentation. If anything else, just let us know. Again, thanks so much for your time, for the opportunity, and I look forward to working with you all soon. Jeff, thanks so much for your help and for hosting us.
Yeah, absolutely. Thank you. And I just put in the chat for those still here that if you want contact information, just go to the AIAOC website, click on the calendar under events, and just go to today's date, and you'll be able to find the information.
Excellent.
All right. Thanks,
wonderful.
everybody.
Thanks so much again.
All right. Thank you.
Thank you. Have a great day, everyone.